Good afternoon to all. So this is my first offline lecture on elasticity unit. I welcome you all for physics course during these holidays. If you have any queries, please let me know during the next online lectures with you. So objective of this unit is, after completing of this unit, so you can able to demonstrate your understanding of elasticity, elastic limits, stress and strain curve, and the ultimate strength of a material. So you can able to interrelate the three types of elastic modulus like Young's modulus, shear modulus, and the bulk modulus. So with all these parameters, you can able to solve the numerical problems which are related to this. These are the objectives of this elasticity unit. So what is elasticity? So you all know that elasticity even before this course also, but so we will let you know from the fundamentals of elasticity. So elasticity is the ability of a body to resist any permanent change to its when a stress is applied on it. So for example, if you apply any force on the material, so there will be deformation produced in the body. So when the material is able to regain its original configuration after removing the applied force, so those material called as elastic materials. So different materials show different elastic behavior. The study of elastic behavior of material is much important. So in all the engineering disciplines which require the knowledge of elastic behavior of the materials and the strength of the materials. So before proceeding to this elasticity unit, we should know about the applications of this elasticity concept. So let me show you one video.
Behavior of materials. In this module, you will learn about different applications of elastic behavior of materials. You might have seen a crane lifting heavy loads on a construction site. The cranes have a thick metal rope so that the attached load does not break the rope under the stress. This happens because the stress produced by the load is less than the elastic limit of the rope. Thus, the cranes are designed to reduce the stress by varying the diameter of the rope as per the elastic limit of the material of the rope. Just like cranes, bridges are also designed in a way that they are not affected by the stress of the load. However, after many years of use, cracks occur in the bridges. This happens because the bridges lose their elastic strength due to the continuous stress produced by the load. Such bridges become unsafe for use. The special design of the bridges we are referring to make use of beams. The beams used in bridges play an important role in reducing the stress such that they can withstand the huge load of moving traffic and people. Let us understand how. Let us consider the case of a beam loaded at the center and supported near its ends as shown. The beam of length L, breadth B and depth D when loaded at the center by a load W sags or bends by an amount delta given by the following formula, where Y is the Young's modulus of the material. We can see that to reduce the bending or to increase the elastic limit of the beam for a given load, we should use a material with a large Young's modulus Y. For a given material, as you can see from the formula, increasing the depth D can reduce the bending to a great extent. But on increasing the depth, the bar may bend as shown. This is called buckling. To avoid buckling, change in both the breadth and depth are made and an I-shaped beam flange is used. This section provides a large load-bearing surface and enough depth to prevent bending. This shape reduces the weight of the beam without affecting its strength. Due to the same reason, a bridge is designed with eye-shaped girders so that it does not bend or break due to the load of the moving traffic. The railway track beam's cross-section is also of eye shape so that it can withstand the load of the train. Not only the beams, but the pillars or columns in buildings and bridges are also designed to reduce stress. A pillar with rounded ends supports less load than that with a distributed shape at the ends. So, distributed shape pillars are preferred over rounded end pillars. Let's recap. There are many applications of elastic behavior of materials. Some of them are use of thick metal rope in cranes, use of eye-shaped beams in bridges and railway tracks, preferred use of distributed end pillars over the rounded ones.
So let me give you an introduction about the elasticity. So when a force or the stress is applied on a material, so there will be deformation in the material. So the deformation may be in any kind. It may be a change in shape or a change in the uh, length or change in the volume. So most solid materials to a certain degree of measure, it exhibits the elastic behavior. So based on the applied force on the materials can be fundamentally classified as rigid, plastic and the elastic materials. So what is rigid body? So rigid body means the body in which there is no deformation in the body after applying the stress on a body. So when there is no deformation means what? For example, rigid body will just example for a rigid body will give for solid materials. Okay, so solid materials means atoms and the molecules are closely packed, tightly packed, so that if you apply a force on the material, so then there will be no displacement from its initial or the original position. Okay, so when there is no displacement of its atoms or the molecules from its original position, so then there will be no deformation. So that's why, so the distance between any two atoms of the body will remain unchanged. So the distance between any two atoms of the atoms will remain unchanged. So however, the large force may be applied on the material. So that's right. So ideally there is no rigid body. So for practical purpose, so solid bodies are taken as rigid bodies. So what is plastic body? Plastic body means if a body doesn't show any tendency to return to its original configuration after removing the applied force. So when you remove the external force on the material, so if the body doesn't show any tendency to original configuration, so then we are calling it as a plastic body. So for example, for this is clay. So it will be in the deformation or the deformed form only after removing the applied force. Then what is elastic body? Elastic body means, so if you remove the applied force, so then the body will come back to its original configuration or the original shape or the original size. Okay, so these kind of body we are calling it as elastic body. So example for elastic body is quartz. So what are the important terms to be learned from this concept? So what is the deforming force? So deforming force means you are applying an external force on the body to deform a material. Okay, so deform a material means there may be change in any kind of a shape or the volume or the size. Okay, so what will happen after applying a force to deform the body? So there will be a restoring force or opposite force which will be created inside the body. So how this opposite force will be created inside the body? So for example, in case of solid body, so atoms are closely packed. So that if you apply a force on the material, so atoms or the molecules will be displaced from their original positions. If they are displaced from their original positions, so now the distance between these two atoms are increased. So these atoms are displaced from their original position. So what will happen? So there will be deformation in the body. The deformation will lead to change in the shape, a size, or volume. So that is called the restoring force. So it is the reaction force developed in the body to counteract the external or the deforming force. So this reaction force developed within the body is tries to bring back the molecules to its original or the equilibrium position. Then what is the stress? When you apply a force on the material, external force on the material, okay, the body changes its form because as I already told, molecules will be displaced from their original or the initial positions. So when they are displaced from their original positions, the molecules develop tendency to come back to its original positions because the intermolecular binding forces are holding back. Okay, so the aggregate of this restoring tendency exhibited by all the molecules of the body manifests as a balancing force or the restoring force, counteracting the external force. So this is the opposite force which is created against the applied force. Okay, so that will be equal in magnitude, but it is in opposite direction. So in general, we can call the stress as a restoring force or the applied force, because the restoring force which is equal to the applied force. So restoring force to the area of its application, that we are calling it as stress. So the unit for stress is Newton per meter square or Pascal. So what is the normal stress? So there are two kinds of stress. One is the normal stress and the tangential stress. Normal stress means the restoring force per unit area perpendicular to the surface, called normal stress. So for example, let me take the shape of a body in the form of a cube. Shape of a body in the form of a cube. Okay. Now you are applying a normal force to area of its cross section. Okay. For example, you are applying a normal force perpendicular to this area of cross section. Okay. So when you apply a normal force or the force perpendicular to the area of cross section, okay, so that we are calling it as a stress force per unit area of cross section. Okay. So unit for the stress is Newton per meter square or the Pascal. Okay. So you are applying a force perpendicular to this area of cross section. Okay. So this is the normal stress. Then the other one is tangential stress or the shear stress. Okay. So tangential stress or the shear stress means, for example, so let me take a body in the form of a cube. Okay. Now you are applying a force parallel to this area of cross section. You are applying a force parallel to this area of cross section. Parallel to this area of cross section. So what will happen if you apply a force, a tangential force parallel to this area of cross section? So each layer of this cube will be displaced or sliding one over the other. For example, h is the height of the cube. If A is the initial point, and this A will be displaced to its A dash. So this cube will be tilting with an angle theta, means this face will be tilting with an angle theta. So each layer of this cube will be sliding one over the other. Each layer of this cube will be sliding one over the other. So it is tilting with an angle theta. Okay. So you are applying a force, but to which direction you are applying a force? Force parallel to the area of cross section of the body. Force parallel to the area of cross section of the body. So that one is the tangential stress. So this is the normal stress. Normal stress means force perpendicular to the area of cross section. Tangential stress means force parallel to the area of cross section. So for both, unit is Newton per Newton square. So if you apply a force on this material, so there will be deformation produced by a body, produced in the body. So deformation means there is change in the dimension or form of the body. So the ratio of change in dimension to its original dimension, we are calling it as a strain. Okay. So the change in dimension of a body depends on how you are applying the force on the material. In what manner you are applying the force on the material. So there are three main types of deformation. So one is the linear strain or the tensile strain. Then other is the volume strain. Other is the shear strain. So these are the three kinds of strain produced when you apply external force on the material in a different manner. Okay. So thank you for watching this. I will continue this online video for the next lecture. So I will explain it from this onwards, from this point.